Hey guys, so we're going to talk about topic 4 of our last unit today. Okay, after this, I'm going to make a video on essential graphing skills you need to learn for grade 9. So, yeah, for this topic 4, by the way, guys, this 80% of the knowledge I'm talking about here is grade 9 first unit that you are going to learn. Okay, so I'm preparing you for grade 9, which is really important that you pay attention and you understand all of the concepts here. Okay, so runoff water. What is inside our runoff water? What does it mean by runoff? So basically, like if you have raindrops and you have rain falling into the river and the river sinking into the groundwater, so that's all runoff water. Okay, so yeah. What is inside the river water normally? If you actually scoop up a bowl of river water, you will find, for example, sand, okay, and you will find rocks, small ones. You can find pebbles, okay. Those are something you can see. Is there anything else that you can see? Maybe sometimes you can see salt, sometimes you cannot. Like if you scoop up a bunch of seawater, you can see some salt in it if it's super saturated, okay. And you can see like organisms, you can see small shrimps and stuff, okay. And you can dead or alive actually, and plants, okay, seaweeds or like planktons, those kind of stuff, okay. And yeah, so and what you cannot see, for example, bacteria, okay. Bacteria is that you cannot see and but can damage you, and you can have living organisms too, living microorganisms. And what else is there that you cannot see? Is there any chemicals inside? If it's polluted, you can, okay, pollutant. And you can see oxygen. You cannot see oxygen, sorry, but there's oxygen dissolved in every single river water. That's why fish and all the living things can live there, okay. And yeah, so all of these are there. So we need to actually just, when we study groundwater, when we study river water, when we study runoff water, that's what we are going to focus on, okay? So brainstorm. What does it mean for a water to be healthy to drink? So potable means drinkable, okay? If I say potable water, that means drinkable water. So potable water is safe to drink. Is all healthy water drinkable? Okay, not quite. Some water is really healthy for fish. So for fish, some waters are okay, but for human, they're not, okay? So some living organisms that's not, human cannot digest. So monitor water quality. So in grade 9, the first unit you're going to learn is going to be monitoring water quality and see the clarity, hardness, and salinity, dissolved oxygen, measure the pH, those kind of stuff, okay? So first thing you can see when you actually have a sample of water in the cup, it's clarity, how clear it is. Is there any like dirty materials dissolved in it, or is there any mud in it? Okay, clarity. So there's nothing to further explain on that. I just want to make it bigger, sorry. There's nothing to be explained on that. Yeah, just clarity is the first thing you can see, okay? You basically can see whether it's clear or not. And the second thing is salinity. Salinity is basically how much salt is dissolved in it. Okay, you don't want a river water to have too much salt, because this fresh water, okay, seawater will have lots of salt, but we cannot drink it. Okay, we want water to be low in salinity. Okay, and then something we can measure is temperature. Okay, something we can measure is temperature. And why do we care about temperature? Because temperature and dissolved oxygen is closely related. That's a really important concept. Why is that? Because if you have a high temperature, really high temperature, dissolved oxygen is going to decrease. Okay, if your temperature, for example, the river is really polluted by bacteria, and the temperature of the river is rising up to 28 degrees. Okay, and that's actually really warm, really hot for river water, for runoff nature water in nature. So if it's 28 degrees, dissolved oxygen is going to be really low. Okay, it's going to be really dead situation for all the fish and the plants inside, because they cannot have enough oxygen inside. So what's the best temperature for the maximum dissolved oxygen then? I would say 0 to 4 degrees Celsius. Okay, that's the temperature that will give you the maximum dissolved oxygen. That's the best scenario. Okay, so I'm gonna change it to my blue, sorry. Okay, so dissolved oxygen means how much oxygen is dissolved in a river. So the more the merrier, okay? And we want cooler temperature. We want 0 to 4 degrees Celsius, okay? And then if we want to draw a graph on dissolved oxygen and temperature relationship, let's say, I know this space is really squishy. I'm going to talk about graphs specifically in the next video, okay? Here I'm just going to give you a preview. So let's say the temperature is the x-axis and the oxygen level, dissolved oxygen level is on the y-axis. How will the graph be? So the temperature, let's say it's 0 here and it's 100 here, for example. As temperature increase, our dissolved oxygen decrease or increase? Think about it yourself. We just talked about it, okay? As our temperature increase, is our dissolved oxygen going to increase or decrease when we go into the water? It's going to decrease. So your line is going to be, the dissolved oxygen should be high around 0 to 4 degrees, okay? And then it's going to gradually decrease as my temperature rises from left to right, okay? A trend line would be like this. It would be a decreasing trend line, okay? If I ask you to draw a trend line, or if I ask you to choose the correct trend line picture for two variables, so for example, dissolved oxygen and temperature, you're going to choose the correct trend line for this, which is decreasing in this case. Okay, so, and the other one we need to measure, actually we can measure it in our household, is hardness. Hardness is just like, don't drink hard water, drink filtered or distilled water. It's basically meaning that how much dissolved minerals are inside. Okay, dissolved minerals are inside. If your tap water, so for example, your tap water is really hard, like it leaves the white traces behind, okay, the white solid traces behind. That means the minerals are settled down the surface. So if you drink tap water for a long period of time, for several years, if you have the habit of drinking hard water, you are really likely to get kidney stones, because all the minerals will actually settle down, accumulate inside your body. It's really painful to have. Okay, so, and the other one we need to measure is pH, how acidic or basic it is. So pH level is one of the really, really important concepts in grade 9. Okay, so pH level range from level 1 to 7 to 14. So basically 1 to 14. And then at 1 to 17, if you test the pH of the river and it shows a pH number of 1 to 6 or 1 to 7, below 7, it means the water is really acidic, okay, which is not good. So for example, orange juice or a lemon would be around here. Okay, and if you dip your pH tester in the river and it shows a pH be above 7, so that means, let's say I'm going to use this one. If it's above 7 here, that means river is really basic. So for example, the soap to wash your hand, will be around here, and milk is a little slightly basic too. If it's extremely basic, for example, lye and a OH, okay, it's going to be really, really basic. If you smell it, it's going to smell really bad. So if you are if you're in the classroom, I'm going to show you an example of a lye that's corrosive. It will eat your hand away, eat your skin away. But here you don't have the opportunity. So unfortunately, I'm just going to tell you, for a pH of 1 or 14 is really, really dangerous because they're extreme pH. Okay, the optimum level, however, the sweet point is 7. Okay, normally water is around 7 pH. That means it's neutral. So water we drink is neutral. Okay. So the next one is bioindicator species. Next thing we're going to test in the river to see whether it's good water quality or not is bioindicator species. Okay, so these are animals. These are small like flies or in the water, or small like snails in the water that will indicate, or fish actually, will indicate whether the water is good or not. Okay, we're going to talk about those later. But however, let's summarize it up. When you test water quality, there's 7 things you can test on. One is clarity, salinity, temperature, dissolved oxygen, how much dissolved oxygen is there. Temperature is important because it's related to dissolved oxygen, okay? And pH, whether it's acidic or basic or neutral, and how hard is it, how much dissolved mineral there are. So bioindicator species, ooh, next page. Bioindicator species, I'm going to just talk about it straight here. Okay, sorry, we're skipping a page, but we're going to get back to it, okay? This is basically detailed explanation for each one of them. So I'm going to talk about bioindicator species here. So these are the species you might find in a river, okay? You might find in a river, and they're divided into different groups. So these are group 1 species. What does it mean? They're very intolerant of pollution. That means they are the spoiled baby. They only live in best water quality. Okay, they are really vulnerable. That means if the water quality is bad, a little bit bad, they will die. Okay, they only live in the good ones, the good waters. So here, group 2 is moderately tolerant. So that means they can live in a little bit polluted water situation. Okay, so group 3 and 4, I would say they belong to, they're tough guys. They're tough. Why? Because they can live in polluted water. Okay, they can live in polluted water, but can they live in bad or good water too? Yes. Okay, they can live in any kind of scenario situation. So they're the tough guys. If, for example, in a river, if you find, for example, in the river you find nymph, stonefly, you find mayfly, you find rifle beetles, that means is the water good? Of course it's good, because these guys only live in good water environment. Okay, if you have a water environment that has these 3 in it, and also this, does that mean the water is good? Yes, because these 3 are in there. They are the proof that the water is good. And at the same time, these 2 guys who are tough can live in any environment, okay? What if you're given a water sample that actually gives you, for example, I only have leech and blood midge larvae, and maybe a clam mussel, okay? So is the water quality good? No, because none of these guys can survive in it, okay? None of these guys are found, only the bad guys and a little bit of a good guy in it. So that means the water quality is not that good, okay? So we use how much of each categories of species we can find to actually make sure that, oh, this water quality is good. So these ones are basically what we look for when we decide whether the water quality is desirable. Okay, let's go back to the details of each one. Clarity basically means this is not murky, clear. Okay, this is high clarity, low clarity. Okay, and if a sample water has low clarity, would you drink it? It's like this cup of water, would you drink it? I would not drink it, because you don't know what chemicals are dissolved in it, okay? You don't even know whether it's dissolved in salt or sugar or something like that. So, like, there's something you cannot see, so you cannot drink it, no. If the sample water has high water quality, can you drink it? No, okay? This question asked about low clarity. So this one you won't drink because it has mud in it. This one you cannot drink either because you don't know anything you cannot see in it. Okay, so salinity is how much salt is inside. Ocean has a much higher salinity than freshwater. Okay, so hardness. See all the scab here. Okay, so that means your tap water has lots of minerals in it, dissolved minerals in it. If you drink a lot, those white stuff will actually form sediments inside your stomach, inside your intestine, and inside your body to form kidney stones. Okay, which is really bad disease. So don't drink hard water, please. Okay, so drinking lots of hard water will actually give you kidney stones because all the minerals will accumulate into a little stone there. pH. Okay, so this is the pH scale we were talking about. Can you see the pH of water? No, you have to test it. Okay, what can affect the pH of a lake? So for example, bleach, if you put lots of bleach inside. So for example, if water is polluted, it looks really dirty and black, right? So people are kind of like, they cheat themselves by putting bleach inside so the water looks really clean, but actually it's really basic in this case. It will make the water really basic. Okay, please remember this example. If some industries just like pollute the water to make it really dirty, but they kind of want to hide it, or the government try to treat it by putting bleach into it. That's not desirable. That's not a good move. But sometimes they do it, okay, to make it look better. So bleach can make it really basic. Let's say, do we have, yes, bleach here. See, it has a pH of 13, so it's really, really basic. So, and another scenario, acid rain. Okay, so industry fumes, bad pollutant, gas pollutant, go into the air and combine with the water droplets in the air and go down to form acid rain. So acid rain usually has a pH of 3 to 4. Okay, it's around 4-ish. So when it goes down, it eats away the trees, eats away so kill the fish inside the river. Okay, it's really, really bad. So acid rain makes the river water really acidic. Okay, just remember these two examples would be good. Okay, so temperature. The best temperature for aquatic animals to live in, which is the maximum dissolved oxygen, is 0 to 4 degrees. Okay, so within this range, the colder the water, the healthier it is for aquatic organism. Why is that? Because the colder it is, the more oxygen will be dissolved in it. Okay, colder the temperature, more oxygen dissolved. More oxygen, the merrier. What might cause water temperature to rise? Global warming. Okay, can you think about some other reasons? Okay, chemical reactions. That means chemicals are dumped inside the water, and the chemicals inside, they react with each other, they release heat, so they heat up the water, which is a really, really bad situation. Okay. Yeah, dissolved oxygen. You can see that the oxygen is the highest around this temperature range. As the temperature increase, the water content, the oxygen content will actually decrease. Okay. So yeah, dissolved oxygen. We talked about bioindicator species. I'm just going to do a recap on this. These people only live in good environment. These people can live in bad. They're tolerant, they're tough. And these people are mediocre ones. Okay. So let's do some exercise on this. First question there. A river is found to have lots of midge larvae and leech in it, but no stonefly nymph. Is the water quality good or bad? Okay, so there are 3 things we need to look for. So, midge larvae and leech, but no stonefly. Okay, where's midge larvae? There we go. And what? Leech. Okay, I'm going to do the first question with you and do the second by yourself. And no stonefly nymph. Stonefly is this one. So no good indicator species, only the tolerant to pollutant species. So is the water quality good or bad? It's really bad. It might be bad, okay? Because only the tolerant ones. So these are group 4 species, group 3 and 4 species. That's why. Okay, and please pause the video and do the rest by yourself. This one and this one, okay? And then let's see if you can get it correct once you get back to me. Okay, let's find out. So a river is found to have some cranefly, leech, but plenty mayfly nymph in it. Okay, is the water quality good or bad? So it says leech, cranefly, mayfly. There's mayfly, leech, cranefly, cranefly, cranefly. Where is it? Cranefly, cranefly, cranefly. Oh, I can't find it. But anyways, I must be blind. Okay, you know what? It's fine. Because we already know that we have mayfly in it. If we have mayfly, plenty mayfly in it. If you have mayfly, that means this guy is really, really intolerant of pollutant. So that means it can only live in clean water. If that is found, that means the water is clean. Okay. So in this case, they're asking you to read graphs. Which side has the best water quality? Which one is the best, is more contaminated? Okay, this is a grade 9 level question, but it's really easy for you to answer. Okay, I'm just gonna build a transition for you to grade 9. So yeah, site 1. So I'm going to just label all of these by their group number. Okay, mayfly and stonefly. So we have mayfly and stonefly as group 1. Group 1, they're the spoiled kids. They can only live in good, okay? So caddisfly nymph is like that. Okay, so caddisfly larvae, that's a good species too. Midge larvae. This one is group 4, and worms. Where's my worms there? Aquatic worms, okay? That's group 4 too. Great. So let's see which is the bad water, which is good water. So site 1 there, do you see mayfly Stonefly and mayfly, they're plentiful. That means this is good. Okay, we're only looking for whether the site has these ones. So site 2 is really good too. And site 3, I would say the good indicator species are really low, and instead the bad ones are really high. That means maybe this is not a really good water quality. These are good water qualities. And this one is mediocre, I would say. You can find some good quality in it, okay? So it's mediocre. And the midgefly, which is group 4, has plentiful. So that means maybe the water quality is on the edge, okay? So if you understand that, which is perfect. Oh, by the way, this part, improving water quality, I would say I'm not going to ask you any test questions on this because that's not part of requirement for grade 9. You're not going to talk about it in grade 9. So I'm just going to cancel this. I know it's already a long lesson, so good job for hanging up there. Okay, so this part here, I'm just going to cancel this part. You don't have to know that part. Okay, and the next video we are going to talk about graphing, so really important graphing skills that you need to understand for grade 9s. Okay, so there are practice booklet in the Dropbox, so please check it out. Okay, yes, good luck.